Hello, everyone. Welcome to today's webinar. I'm Pamela Deason, Head of DevOps Product Marketing here at Broadcom. Today's webinar is going to be led by Abhijit Magali, who's the Product Manager for Test Data Manager. And he is going to be joined by Trupti Abagi, Raghav Sharawi, Hudson Santos, and Daman Zarir, all of whom are client services consultants. They will be doing the demos following the presentation that Abhijit presents. During the presentation and the demos, you will be muted, but you can enter questions on the tab on your screen. At the end of the presentations and demos, you will be able to unmute yourself and ask questions directly of any of the panelists if you choose. The presentation is being recorded, and afterwards, I will be sending out a link to the recording to anyone who registered for this webinar. Also, be aware that in the handout section, the PDF of this presentation is available for you, and you can right now download it. And as well as in the download, just so you're aware, I did put some marketing slides. By that, what I mean is we do have office hours and newsletters, communities that you can sign up for. So please do download the presentation and take a look and see look at all of the ways that you can engage and communicate with this team and myself. So with that, I am going to turn it over to Abhijit. Abhijit?
Thanks. Good morning, good afternoon, or evening, depending upon the part of the world you're joining in from. I would like to welcome you all to this webinar on what's new in Test Data Manager 4.11. My name is Abhijit Mugali, and I'm the product manager for TDM. On this call, I'll quickly go over some of the key marquee features of this release, but a majority of this call would be essentially around the demos of these marquee functionalities. And at the end, we'll have time for your question and answers. 4.11 was a very significant release for TDM, and we delivered a bunch of marquee features in the areas of usability, scalability, as well as native NoSQL support. Starting with the usability, we have entirely revamped the portal UI to move from the AngularJS to the React framework. What this means is it enhances the usability across the board, but also improves the compliance with respect to VPAD. In addition to this, we have delivered a new workflow that unifies the PII scan, mask, and audit functionality. Enterprise scalability continues to be our key focus area, and we have delivered our next innovation in terms of scalable masking that allows you to horizontally scale masking jobs. Additionally, we have added support for SAML protocol for the TDM portal. And last but not the least, this release marks our first iteration in terms of providing comprehensive native support for NoSQL databases. So this release extends our support to Cassandra, MongoDB, and BigQuery. I'll go briefly into the marquee features before the demo to set some context, starting with the unified PII scan, mask, and audit functionality. A lot of our customers are facing increasing regulatory pressures to demonstrate compliance in their environments. Traditionally, we have had multiple functionalities like masking, auditing, that helped you in terms of demonstrating compliance. However, one of the challenges which our customers expressed was that all of these functionalities were sometimes disjoint and there was no unified view available to demonstrate compliance. This release, we redesigned our workflows so that you can have a unified workflow across the scan, mask, and audit functionalities. This includes several things, starting with the common scan engine that ensures that both your masking and audit work off a common scan engine. It also extends to independent environments, which can be defined for your data models. Now we support multiple data models per project, per version. The other challenge with doing a PII scan, especially for large application, was that it was time consuming. And in teams which essentially follow the agile methodology, doing this on a sprint basis was becoming a real challenge. So with this release, we have introduced a delta scan functionality, which can detect delta changes without the need to perform like a full scan. And last but not the least, we have introduced the ability to clone our FNR models. The next feature is around the scalable masking. As you might recollect, we introduced the ability to Dockerize masking, starting with the 4.8 release. We had several customers who are taking advantage of our horizontal scaling. However, as the data volumes have grown, there were two additional challenges. One challenge was around the infrastructure. What it means is that when you want to do a large masking job, you have to provision a large machine in order to do this masking. And given that this was an activity which was probably done a monthly, quarterly, or even a bi-yearly basis, it became an overhead in terms of the infrastructure. Secondly, when you have to mask large amounts of data, there is admin overhead in terms of the configuration. So our next iteration of the scalable masking tries to address these two challenges. With the 4.11, we have the ability to deploy masking jobs on a Kubernetes infrastructure. And depending upon the volume of the data, the infrastructure can scale in and scale out in terms of the masking jobs. We leverage something called as a CADA framework, which allows you to auto scale in and out. What it means from a customer perspective is that you can point to a data that needs to be masked, and we can automatically figure out like the number of masking pods that are needed, bring them up, perform the masking actions, as well as bring that down when the job is completed. This addresses the two key challenges in a sense that it takes advantage of elasticity of the Kubernetes infrastructure, and also it reduces the admin overhead associated with large-scale data masking. In many of our customer environments, TDM has become a critical part of the DevOps infrastructure. In order to better support the enterprise needs, we have delivered the single sign-on authentication using SAML. TDM can support multiple identity providers, including Okta, Ping, and several others. The framework is also extensible in terms of adding new identity providers as and you have those requirements. Last but not the least, we have started to deliver native NoSQL support with this release. For this release, we have targeted and delivered 3 databases: MongoDB, Cassandra, and BigQuery. The support is across a broad range of TDM capabilities as listed on the screen. One of the notable exceptions is the subset functionality, wherein we have decided to do on a case-to-case basis. However, for the other set of capabilities, it is comprehensive, and we have taken care to ensure 2 things. One is around the performance, for which we have published the benchmarks in the documentation. And the other one is around the support for database-specific data types, including collections like list, maps, and several others, which we'll cover later in the presentation. Also, one of the notable additions is a new data generation engine that supports data generation for hierarchical relationships. Our intent is to provide a much more comprehensive NoSQL database support, and this should be an ongoing work in the upcoming releases. Although these have been the marquee features, we have delivered close to 40 plus enhancements, which are very targeted around your needs for performance, usability, as well as functional enhancements. Also, I'm happy to announce that we have several customers who are already in production with this release, and we look forward to much more customers utilizing this in the future. So with this, I'll hand it over to Daman, who will essentially provide the demo of one of our first marquee features around unified PII scan, mask, and audit.
Thank you, Abhijit. Like Abhijit said, my name is Daman Zarir, and I'll, can you see my screen, Abhijit? I will be demoing the unified PII scan, mask, and audit. And also I will be introducing you to a new find and reserve feature called FNR, cloning. I have added 3 slides highlighting the new modeling concepts and providing another view to the new features for you to look at when you will be provided with the PowerPoint presentation. So without further ado, let me start the demo. Sorry, before delving into the demo proper, I would like to let you know that we have moved our UI interface implementation, like Abhijit said, from AngularJS to React.js. So if you are familiar with the older TDM versions, you will notice that the UI interface has drastically changed, and hopefully you will agree with me for the better. As a side note, the landing page did not change, as it is still in Angular and will be moved shortly to the React framework. So let me start by creating an environment to generate a data model. By the way, data models are a virtual representation of a target database. In TDM, the primary task for PII scan, PII audit, masking, and find and reserve is to first create a data model. So, as you can see, the interface has changed from previous version of TDM, 4.10 and before. So now I'm going to create environment 1 with specifying a connection profile for this environment. So let me pick up one. This is the connection profile I would like to use for this environment and save it. Now let me go and double check that connection profile I can filter that by specifying the name here, and that will give me the connection profile that I'm interested in. And as you can see, the UI has changed and confirmed that the connection is okay. Right. So now let's go back to the environment, and I'm going to create my my data model. So I'll be scanning my data model. Let's call it data model 1 based on environment 1. And I would like to filter filter based on, let's say, selecting specific set of tables. And in this case, I'll be creating sort of a data model based on tables that are starting with C, and scan. As you might have known, data models are stored in our TDM repository and represent the target database metadata, including the tables, the columns names, and the data types, as well as the relationships, among others. Previously, in older versions, you would be limited to one data model per version. Now, there is no limit on the number of data models for each environment. Okay, so now we have created our data model. So the main purpose, for this first task is to show you the Delta PII scan functionality. So to do that, I needed to create the first model 1, and then I will generate a PII scan based on this model. So let me do that by clicking on the action and do the PII scan. Okay. So I selected some classifiers. So by the way, I'll take all the default settings for the rest. Classifiers are, and scan. Classifiers are a set of entities containing regex expressions and lists linked to their own tags. So these entities are then used to scan the data, and when there is a match, we set the corresponding tag to the column. So that has completed, and then you can see here that we have a sort of a heat map displaying the PII scan result. You'll notice that each square is a table, and if I zoom in, you'll see more details about the table name as well as the other information related to the table. And if I click on a specific table, I can investigate by looking inside to see what are the tags that have been assigned for each column. I can add manually. I can delete tags that maybe I don't agree with. And also I can view data from the table by displaying this random rows. And that sort of gives me the information, and can refresh and gives me the information about the data that are stored, and also helps me deciding on the tagging for the columns. So now I'm done with the first model, model 1, and then I would like to create another model so that we can do the PII delta scan. For that, let me go back, for example, to rescan a new one. Let's call it model 2. And this time I will add more tables. So what I'm trying to do, we're trying to show you how to create a PII delta scan by making sure that the new data model, which is in this case model 2, and based on the same environment 1, as model 1, will be detecting a new set of tables. And in this case, starting with, I would pick up A. So in reality, a database is a dynamic entity where tables metadata change over time, as well as new tables get added and old tables get removed. So the PII delta scan would entail first doing a diff between the previous model 1 and the recently being scanned model 2. And then to extract the changed or added tables before performing a PII scan on those tables, on those new tables or change tables, so that the tables that did not change between model 1 to model 2 will not be scanned, because there is no need to do a scan for those tables. So now I'm going to do a PII. So I can have a choice. I do have a choice between PII scan or PII delta scan. We want to do, and this time the configuration will be used. From the first scan on model 1 will be used, because we don't want to make changes. Otherwise, it does not make sense to do the delta scan. So now this is the result of the PII delta scan. There is a new button added on the screen, on the heat map, where it says delta tables only. So if I select it, it will exclude the ones that did not change or newly created tables, and therefore only show the tables that changed. In our case, so yeah, by changing, there is a slight difference, you'll see. Yeah, so that means that when you look at the table names, you'll see that we are looking at the tables that starts with A, because these are the tables that were added between model 1 and model 2. Right, so now, like I said before, if you click now let's move on to the PII audit functionality integration with the PII scan. So in this case, what I would like to show you is that if, let's say, we investigate a specific table, so as an administrator, I will be able to, let's say, create new tags, remove tags that were detected, and then go through all the tables. So, for example, here I would say I want this one is maybe it's a town name, maybe, and the reason is added by admin, and so now I have added a new tag, and then I can confirm and then decide for the rest, all the tables. So for this case, what I will do, I'm going to select all the tables and then confirm them. At this stage, I will be able to create a report and send it over to the data analyst, security analyst. So let me create a report. Now I need to download to view the report. So the report is simply a PDF file that will allow you to, that stores the information related to all the tables, the classifiers used, the columns, data types, the tags against the columns, even the ones that I manually added myself. So that information is stored in this PDF file so that the data analyst eventually will be able to review. So let's go to another tab on my Chrome where I am logged in as user 1. So this user, let's say, is the data analyst to review, either to sign off or to reject the report. So let's see. Okay, that's closed. Sorry, I did not sign off yet. So sorry, I went back to the administrator view. I logged in as administrator. I'm the one that created the, that checked the heat map and confirmed all the tables. So now I'm going to sign off so that the data analyst will be able to review. So that's done. So I go to the other tab for the data analyst to have a look at. So let's see, that should be will be possible to view the new entry. So here I have a new entry, and it shows that user 1, which is me, that I logged in now, is a job reviewer. So I can click on it, and then I need to download the PDF file again. There are two options: either download the Delta or download the full PDF file. The Delta only contains the tables that have changed or added between model 1 and model 2. So here I'll download the PDF file, the full PDF. It's the same process. So the data analyst, security analyst, will be able to review and then decide what to do. So after reviewing, I can either, let's say, I'm not happy. Column 1 has the wrong tag. Okay, remove, please. So that can, and then I'll reject it. So that can go back to the administrator that created, the report first place. So here I come in. Let me go back to the model and the model 2. So go back to the heat map, and now I can sort of, I can decide, I made a mistake, investigate, change the what have been asked. So undo the confirm, remove this one, removed, and then sorry, not add, sorry, it's remove tag. Okay, removed and done, and that will unconfirm and close. So now I am done. I will send back the report, download the report for me to review, and then to be able to sign off. Now the user the user 1 will be able to have a look. Let's see. Okay, I'm the user 1 or the data analyst, and this time I'm happy with the report. I'm not going to reject it, so I'll sign it off. Okay, and that would store the report information in the reports section. Okay, so that's the report section where you have the executive summary, the job summary, the audit report for review later on. So that shows the integration of the PII scan along with the audit report, or PII audit. In the past, we used to have two separate engines. If somebody wanted to do a PII audit and masking, they would have to run separately a model scan and then a PII scan to do the audit, and then do another completely new model scan again, PII scan, and then masking. That has been merged into one engine to allow our customers to be able to run both PII audit. So when it's done, then be able to decide on masking after the audit has been completed. Now for masking, I can go back to my model 2 and then go to view masking configuration and be able to decide which column, which masking function I want to use for whatever column I want to mask. And that can be done through this editing or adding the masking group, function group. At this stage, I will not be demoing masking because somebody in my team later on will be providing that demo. On that, I will move to find and reserve cloning feature. So let me show you again. So in this case, let me remove this, or let's go to version demo 1, version 2. Okay, let me just, okay, demo 2, I'll add another version. Let's call it version 2. And save. And then I'll be going to demo 2, version 2. I'll create environment again, environment 1 with data source, and then I'll use, sorry, I'm using user 1 that has limited access to different connection profiles. So let me go back to the administrator that has more access. Sorry, and let me refresh this page and go back again and go to version 2. So now again, the environment, I need to create environment 1, so 1, and then I will be able to pick up the same. Again, we'll start with C when we scan the data model. So starting tables with C here. So we call it model 1, environment 1. And then I'll filter again based on table, starting with C. Okay, so now we have the, now I'm interested to create a FNR model. So create model, which based on environment 1, and I'm using model 1. And let's call it FNR, FNR model 1. And I'll be using on demand. And this time I'll be interested to pick up cities, name, and as well as countries, name. Okay, it detects automatically there is a relationship between cities and countries, so that confirm that. Let me edit the name for countries just to make sure we have the right information when we display it on the FNR Find and Reserve page. So we have country name, and this one would be city name. Okay, finish. Now I will be able to go to the page to service catalog, where I can have you can see the tile view has completely changed. The icon here is to do with Find and Reserve, and then I'll be able to reserve based on this particular FNR. Now, what I want to again, I want to show you the FNR cloning. So I'll create another environment, environment 2. And let's say data source, again, the same table, a database or connection profile, sorry, and then generate scan, sorry, model 2, environment 2. Okay, so this time again I'll be interested in starting with C and also with table starting with A and scan. So in this case, with this second one, in a way you have two teams. The first team is using their own database, and then they create an FNR model. And then the second team will be able to find that, to clone the FNR model from team 1 and clone it into their own model. So that they can do their own find and reserve based on their own database. So that's completed. Now I go back to FNR and I would like to create a model. Environment 2, model 2. Oh, sorry, let me go back. There was an issue here. Sorry. Here we have the clone model. So we have the first model, FNR model 1, and then I want to use it to clone my model. So as you can see, we are cloning from environment 1 model 1, and then we want to clone to our environment as team 2. So it would be environment 2, and then we are using model 2, and that will allow me to create my clone. It's again the same. That shows all the information from the previous clones, cities and countries, and then I can add, as I like, different maybe airports if it is linked to one of the tables. Airports, maybe. Let's see. Let's have a try. And then here it would be, let's say, description. Just to, okay, I detected the relationship between airports and cities. Done. So I have, I cloned the FNR for model 1, and then I was able to edit it and add another table and another column to the FNR model. On that, I have concluded my presentation. Will be handing over to Raghav that will be dealing with the masking scaling. Okay.
Thanks, Daman. Hello, everyone. My name is Raghavendra Shirali. Now I am going to cover scalable masking in Kubernetes with Test Data Manager. We will talk about how this is being done with a live demo. Data masking is an important topic because we know that production data is potentially the highest quality of data against which we want our integration testing, system testing, user acceptance testing to go on against. However, the production data, of course, comes with its own demerits, which is we risk the exposure of PII, PCI, and PHI data elements. Because of many of our customers with increasing data volumes and with the lower cost of storage, most of them now wants to have a large subset or potentially a fully representative of production set of data in their lower environment to test against. But that comes with its own set of problems, and these are some of the examples which we see at the ground. So we have seen that a large financial customer, they need to mask around 20 terabytes of data for some of their internal applications. One of the largest healthcare organization, they need to mask around 1 billion of rows in less than 4 hours time to support the DevOps and their automation initiatives. So this is when, for a truly enterprise grade masking or a scalable masking, scalable masking by using Kubernetes comes into the play. The Kubernetes deployment of TDM comes with an automatic scaling and automatic scale out functionality, which means depending on how much information is there to mask, how many tables and how many rows of data are there, TDM will be able to scale out additional Kubernetes pods which can perform the masking. And within each of the pods, we can have multiple FDM engines as well. So not only we can scale horizontally by adding number of pods, we can also within each pod, we can, as I mentioned, we can have a multiple FDM engines as well. We also deploy an optional throttling mechanism, which lets us to control how many pods and within each pod, how many FDM instance can actually spun up so that it is deployed using the auto scaling functionality with Kubernetes. The automatic scaling has been achieved by using KEDA. KEDA is a Kubernetes-based event-driven autoscaler, and by using KEDA, we deploy this auto scale out and auto scale functionality. So I will quickly demonstrate what we just spoke about. In today's demo, we will see a TDM is being running on a Kubernetes environment, and we will see one pod which is running the data masking engine, and we will perform the data masking function on the TDM portal, and we will see how the masking pods are scaling up and scaling back and comes to the base version. With that, I'm going to switch to the TDM portal. So here we have set up a TDM portal on the Kubernetes cluster. For this demonstration purpose, already created an environment. We already done a modeling of the environment. And if I go through the data model, so we have a database with a large number of tables, and each table has large number of records. From this data model, we have identified a couple of tables, couple of large tables, as the PII data and against which we would like to perform the masking. So once the PII modeling is done, I'll switch to the data masking part over here. In the data masking, we will be given an option to choose the data model against which we would like to perform. So in this case, I have one. So I will select the data modeling. In the next screen, it will show up all the tables and its related columns which are being identified as a sensitive information. Based on the tag, TDM itself has proposed the masking function. However, we have a capability to update the masking function against a particular column. I will keep whatever the TDM has proposed for a demonstration purpose, and I'll proceed to the next screen. In the mask settings screen, to keep it simple, not going to change any of the parameters. However, I will keep everything as default. Compared to the previous version, here you can see most of the parameters are being populated as a default values. That means either you want to change those values, you can change that, or you can keep those values default. To achieve the scalable masking, I would like to inform, rather tell the TDM that we are going to perform a very large table masking, because and I'm going to enable a masking parameter, rather a masking functions where it tells large table split enable equal to Y. Once this parameter is enabled, TDM by default, it will start processing the table which are having minimum 1 million number of rows. This is a by default number. We'll keep rest of the other parameters or the functions as it is. Moving on to the next screen, here we are going to perform the masking against only the confirmed tables, and we are not going to mask the tables which are not masked, not marked as PII. This is the summary screen where it talks about what is the model ID being used to mask, against which environment we are masking. Are we masking against whole environment or a particular connection profile? Are we running the masking in a preview mode, or are we storing the masking samples? And we are going to submit the masking job as an on-demand. Right now, we are not going to schedule for this demo purpose. If I click the mask icon here, we will be shown with the disclaimer. It's talking about, are you really want to mask? So before I confirm this and submit the masking information, would like to switch to the Kubernetes environment and show a couple of things. So right now I am in the Kubernetes environment where we have set up the TDM on the Kubernetes infrastructure. With the TDM portal is also being set up. That's what being used for the demo purpose. Along with the TDM portal, we also have one masking engine being running and supported by the messaging and OrientDB ports as well. And when we look into the TDM masking log, where we can get a couple of information about what is the current masking jobs being run and what is the status over here. So at present, we are not running any masking jobs in the TDM portal, due to which you can see the value being shown as a 0, and the target state indicates that how many masking pods are being currently running on the Kubernetes environment. We will measure a metric called number of active masking tasks in the TDM, which is being pulled every 30 seconds to check any masking job is there, and if it is there, based on the number of number of rows, number of records, large tables, TDM automatically calculates how many pods required and how many masking engines needs to be required. So currently we are not running anything, so currently it's 0. So with that, I'll switch back to the TDM portal and I will confirm that I would like to do masking, and I'm going to submit a masking job. Once I submit the masking job, it will be submitted to the engine, and here we can see the TDM will take that job and it will try to calculate how much table need to be masked. So now you can see that value is now increased to a greater than 0 value, but rather a value is showing been 5, and but currently we have only one TDM pod being configured. So if I switch back to the screen and see what is going at the back end, since the TDM has identified that 5 masking jobs needs to be created, it horizontally scaled up 4 additional masking engines, and one is already running before, so totally 4 plus 5. So 5 masking pods it automatically scaled up, and it's trying to bring those pods online. While this trying to come back online, it will try to download the configurations being submitted via portal, and what happens here is we have put some kind of a liveness to the pods, which means that Kubernetes will check every particular second is the pod is up and running with all the configurations, and it is ready to accept the masking job. Now while we talk, we can see that all the pods are now in the running state, all were come up and running. And if I switch back to the TDM portal and see what is happening at the masking job which we have submitted, we can see that all the pods are now started masking against an individual table. 5 tables we have submitted. Each of the pods are executing against a particular table, and it is kind of masking the records. So once this particular pod performs its masking job, it will terminate back once the job is done, and we can see that those masking pods are now being terminated back, and once all the masking is being done completed, still we are left with the 2 jobs. Once the entire masking is completed, we'll see that the additional pods are scaled down, and we will have 1 pods being running as we saw before submitting the masking job. We still got some more masking pod to be running. Let's just go back and see that. And one is getting terminated, and other one is still running. So this is kind of demonstrating how the scalable masking works in the Kubernetes environment. So in order to set up the entire thing, so we have done the TDM implementation of in Kubernetes using the Helm chart. So Helm chart basically provides a few set of configurations. As I mentioned, you can change few configurations here. For example, I was talking about the polling time, right? So currently, as I mentioned, so we do a polling interval of every 30 seconds to check any new masking job is being submitted or not. So these kind of parameters you can change according to the requirement and implementation, and depending on that, the Kubernetes engine will perform. I also talked about an additional parameter about throttling. So throttling allows us to limit the number of concurrent masking jobs, per masking tasks per job. So there are few throttling parameters or mechanism has been added in the 4.11 to support the scalable masking. So one of them is throttling per job. So we can limit by default. If I switch back to the parameter, it's in the masking. So here is the parameter. It talks about how much, how can you can limit, rather you can limit the number of concurrent masking tasks per job, so that it doesn't overload the target database. Additionally, out of the Kubernetes environment, we also added the throttling mechanism on the connection profile. So if you have created a connection profile over here, and if I come back to this, we have added up an additional option, comes under extra option, which we can limit here, maximum. Here we can limit, we can also, rather we can enforce the maximum number of concurrent masking tasks per connection profile if we don't want to handle within the Helm chart. So so this concludes my scalable masking. Before I hand over to the next speaker, if I go back and have a look about what happened to my my environment, we can see that the masking pods which were created were all terminated. Their purpose is done, and we are having one baseline masking job pod which is still running, and back to the masking engine and see what it is doing. And we can see that there is no more masking jobs needs to be executed, and all whatever submitted, those are completed. So with that, I conclude my scalable masking, and I would hand over to the Trupti.
Yeah, thanks, Raghav. Hello, everyone. My name is Trupti Bage, and I am going to show you the MongoDB data generation. So before starting with the data generation, let us see the MongoDB document. So here I have one database called products. Inside it, I have a collection called transactions. So collection is equivalent to tables. Inside this transaction, I have one document. So MongoDB is a schema-less database. So TDM models the schema based on the documents that are present on the table at the time of model scan. So it is mandatory that when we are doing a model scan or a table registration, there should be at least one document in the table, and it should have all the fields for which you want to do data generation. So currently here I have only one document, and we will see that it has ID underscore ID is the primary key, which is of type object ID. And then we have account name, account ID, bucket start date, and date, which are of type string, number, and date respectively. And we have another field called transactions, which is of type array. And if we expand the transaction, we see that it has 3 elements, and each element is of type object. Object is again same as document. Inside this object is a kind of container, so it will again contain different fields. So it has various fields, and all the 3 objects are homogeneous, that is they have the same fields and data types. So now let us go do data generation for this particular table. So for this demo, I have already created an environment for this one, and I have also scanned the table. So if we go to the data model, we will see how it has been modeled. Products, transactions, and then here we see the first level fields are shown here. And since transaction is a nested type, it has some child elements. And here we are seeing the data type, which is array. So when we expand this field, we will see that there is an unnamed row which denotes the element type of this array. The element type is document or the object. So since it is a container, it will have more fields inside it. So we will expand and see these fields, date, price, etc. So for doing data registration, we have to register this table. So let us do the registration. We'll select the table. Click on register. So once it is registered under the data generation section, we will see it under the objects. We can also register directly from here instead of from the models. And so now it has been registered. Let us go and create a generator for this. Under the generator space, new generator. Say I will call it demo MongoDB. And in the DB type, you have to select NoSQL for the NoSQL databases. Now double click on this generator for editing, select tables. So here you will see all the registered tables which are of type NoSQL. Since this is a NoSQL database generator, select the table and we will see all the fields for which we have to provide the data generation rules. The first field is _ID, which is of type object ID. For this, we have provided a new meta function called object ID, which generates the object ID, the data required for this data type. So for account name, let us give some randoms like company names. Since I have used this field earlier, so we can see it in the cache. So I'm populating it from there. For account ID is of type int64, so we will give some big number. And bucket start date is of date time, so we can use some random date. And end date, I want my bucket to be of say 30 days. So for this, so whatever value generated for bucket start date, we want to add 30 days to that and use generate the value. So for that, we want to refer to this field, so we can do that. So we'll open the data painter for this. Use the function add days. So date, the first parameter is date to the date which we want to add. So I want to add say 30 days to bucket start date. So here you are seeing the transactions, bucket start date, the table name dot the column name, and days say 30 days. Insert. So as soon as we insert, it will be auto validated. Now coming to the transactions field, which is of type array. So for array, we have to define how many elements we want to generate for the array. So for that, we have a field called array generation count. It takes integer. So let us generate some random number of fields. So I am giving some range between 1 to 50. And when we expand this array, we will see the element type, which is of type document. Again, we have to expand it. Then we will see the fields inside this document. So for this date, since this is a transaction for this bucket, I want the date should be between these two dates, the start date and date. So again, I will refer to these columns in this rule. So I already have saved it. So I'm generating some random date between transaction bucket start date and end date. And for price is double, we will use some rand range function to generate some double value. And quantity is an integer 32. So some random number between 10 and 100. Symbol, for symbol, say we don't want to generate, we want to set it to null. So for that, we have an option called set null, set to null. So this set null option is available for all the fields. For whichever you want to set null, you can select it. And once set null is done, you will see that the field has been grayed out. And while publishing, we will be publishing null for this field, except for the mandatory fields where ID is a mandatory field. So you cannot set it to null. So in that case, we are not showing the set null option. And then for total, again, so we have, as of now, we have referred only to the columns, to the fields which are at the top level. So for total, I want to use multiply the price and quantity, which are inside an array, which is an array element. So we can do that also. So for total, let us open the data painter again, and we will use multiply function here. And the first number will be, so here we are seeing all the columns, transactions. So first number is say price, and the second number is quantity. So here you are seeing this is the first table name, and then we have the field name, which is again transaction. So here you are seeing an array symbol because this is to denote to the user that this is an array. But in the rule, we don't use the array symbol. It is just the field name. And inside transactions, the quantity, the price field, which we are referring to. So click on validate. For transaction code, we don't want to generate. So in case of symbol, we want to generate with a null value, but in transaction code, say we don't want to have this field in our database. So for that, we have another option called exclude. So once a column is excluded, you will see this field will be striked, and this denotes that this column will not be published. And we have another Boolean field for which let us give some function which generates a Boolean. So we have defined all the data generation rules, and also we have in case of MongoDB underscore ID field, inserting underscore ID field is not mandatory. It's not mandatory because MongoDB generates it for you if it is not present in your document. So either you can use the object ID function to generate the object ID values from TDM, or if you want MongoDB to generate it for you, then you can exclude this field. So let us exclude this also. And we also want to create some publish actions. So create publish action. Say I want to add one more field which is currently not present in the schema. Since the MongoDB schema is based on the documents which were present at the time of model scan. So suppose one of the field was not present and I want to add it. So we can do it using publish action. So let me call it add field. Provide some description. Action type is SQL, and for MongoDB connection profiles, we stored SQL is not supported, only direct SQL. You have to use direct SQL, and in connection profile, again, target and source types are not supported. You have to select the exact connection profile on which you want to run this action. We have once the connection profile is selected, we see this set of fields where database name has been populated from the connection profile, and collection name we have to select. Since we have only one, we'll select transactions. And operation type, we have find, insert, and update and delete option. So since we want to add a field to all the documents which we are publishing, we will use an update operation. And for update, we have to give some filter, like which documents you need to update. So if we want to update all the documents, we can just simply give an empty array, empty filter. But say I want to update only those fields in which the primary is primary. We have one is primary field. Its value has been set to true. So so this is the filter we will be giving. This filter is MongoDB query filter. And in the document, we have to give the pipeline aggregation query for update. So I have one example here. So what this will do is it will add field. The field name will be type, and the value is primary. This is of type string. Wait for completion. And we want to execute after our data has been published. So we will select post. Save. Now we will go back and do the data generation. We'll go to publish. Select the connection profile. Select schema, which is products. And the number of documents you want to publish. So let us give 10. I already have one document and we are publishing additional 10 documents. So my job has already completed. We'll go back to the Mongo Compass and see the generated records. We'll refresh the data. So here you are seeing the data which has been generated. So here is primary equal to true. So the type primary has been added. This field we have added through the publish action. And if you go to some other record where is primary is false, so in this case you are not seeing the type field, because we said we need to add this field only for those documents in which is primary has been set to true. So if we see our generated document, yeah, we have excluded the ID, but see MongoDB has generated it for you. And in transactions, we again, if we see the different documents, the array, the size of the array is random because we generated random numbers. And if we go to each of the object, so for the symbol, we have set it to null, so it is generating null. And there was one more field which we had excluded, the transaction code. So this field is not even present in the document. So this is how the MongoDB works. And you can also publish through a file. If we go to publish, we can select file. So here we have only one option, NoSQL database specific format. For MongoDB, it is JSON. So let us publish 5 records. So it has completed. Once it has completed, we can download the published data. We'll go to the downloads. So this is the file transactions.json. If we see the data, it has generated an array of, it is a JSON array. We can use this file to directly upload in MongoDB. So currently we have 11 records. We can import this file. So 5 documents have been imported. Now if we refresh, yeah, we have 16 documents now. Yeah. So this concludes the demo for data generation for MongoDB. Now I will hand it over to Hudson who will be demoing you the masking.
Okay, thank you, Trupti.
Pam, can you hand it over to Hudson?
It is with me, I guess. Hopefully you can see my screen.
Yes.
Okay. So hello, my name is Hudson Santos. I'm been working for TDM and Broadcom for 5 years. I'm located in Prague, Czech Republic. So talking about masking, NoSQL support. Okay, so NoSQL support, we have 3 databases that we support nowadays, which is BigQuery, Cassandra, and MongoDB. All of them are different from each other. Okay, they have primary key is not supported, masking for primary keys, and we have the complex types for them. The complex types, each one has their own name, but in the end of day is the same. They are the same. Okay, for that we had a new notation which we include dot in the name of the columns, like we are familiar in the view that we are seeing. Okay, for BigQuery is a different database. There is some limitations in their side, so we need to build a new framework for that, just for BigQuery, right? So we do the masking in a different way that we do for normal databases or Cassandra and MongoDB. For BigQuery, we need to have a temporary table where we write all the records updated, and then after that we pass over the merge process, and this merge process will pick up this temporary table data and save it into the real table. Okay, and after that we delete the temporary table, and then is the end of the process. Okay, so for BigQuery we support the simple types and the complex types. The complex types are array, and call it the complex type that is different from the other database is record in this case. Record means a complex type that you can have object inside of the database, right? So you can have multiple fields inside of this complex type, this record. Okay. For Cassandra, also, we have some simple data types and complex data types. Now we don't have 2, but we have 4. So we have list, set, maps, tuple, and UDT, user-defined types. Okay. To mask for Cassandra, complex types needs to be done by XPath. This will be automatically generated by the portal. You don't need to be worry about that. We are going to do it for you during the time that we are doing the scan. We are going to identify that is UDT type, and we are going to generate, for example, the XPath for you automatically. Okay. People that is familiar with Cassandra will be familiar with this allow filtering. So I'm not going to be in details on this case. Okay. Okay, so coming to the MongoDB also is a different database. We have simple types, which is string, integer, double, and Boolean, date, and typestep. The complex types are array as BigQuery and document. Document is for BigQuery is equal BigQuery record. So you have that. For masking, we use super document. We call it super document because we need to read some portion of the database to look for the structure from the documents. And based on these rows that we read, they can have the different fields from each other, and then we build these super documents based on the all fields for the all rows that we are passing for. Okay. We don't have a defined schema for that. We just need to read the database to get it. We also support vCLOS in MongoDB, but this is only for MongoDB. We need to build some kind of framework that makes it easy. In the MongoDB, we don't have a normal select star from where. So the MongoDB is like Drupti said, is filter. They call it filter. Then we created this filtering. Now you don't use the filtering, but use this key for that. So here we have an example that we have for comparison. For example, we want to get in the document that has a field 1, for example, and the value that we have inside of the field 1 should match with 10. Okay, if we have 10, then we are going to mask it. Okay, and there is also the operators. There is some logical operators. We don't support all of them, but the major part of them is being here. Okay, then it's time to do the demo. I'm going to go for demo now. So, okay, so as I said, the MongoDB, Cassandra, and BigQuery, they are different from each other. They have a lot of particularities that is different from each other. So I'm going to show you the BigQuery, which is the most different from the others. I think you are familiar with the other databases, but BigQuery doesn't have the normal fields like username and password. For that, we need a service account for that. And for service account, we use files to be authenticated with Google. So you create a service account, you need to go for Google and download it, download the file for that, and then you drop it here or click here to put the file for that. Okay, so you can see here I have one file. When you do that, they are going to upload it. In this case, it's already there. You don't need to be worry about that. So for Cassandra, I'll be passing for it. Just normal. You just need to see and fill the field that is required, and you are familiar with that. For Cassandra, for MongoDB as well, same. We just have here some other fields, and we have everything. Okay, I have prepared the MongoDB masking session for that. So we have this module here, press scan. Like first step is coming to environment. Create environment, then we go for module, we scan it, we create this environment, we have a connection profile like the other did, then we have a heat mapping for that. So here we have one table, and then we have some tags for that. Okay, after we have this tagging, we are able to see the model over here in this session of the masking. Then we can go for the module. We have the view for tables, so we can see here the tags that has been assigned for the columns, and here we can have the masking function. So here you can see what we are going to do with this function, what we are going to say for that. So some of them has everything. Okay, the important part for us, this is NoSQL database, is this. This is the complex type. We have array of documents in this case, which has cities, countries, number, and postal code. And then also we have array of simple type, or array of number in this case. Okay, I can show you the format of one record that I have here prepared. We are going to see that after the process, this record will be masked. Okay, okay, business as usual. Probably you are familiar with this screen here. The only difference that you can see is this. For BigQuery, Cassandra, and MongoDB, we have the same format. Okay, so if we have the complex types here, we are going to see it this way. Let me check the Cassandra one. There is one model here. I'm going to try to show you the UDT, right? So you are going to see that is automatically generated. The XPath should be generated. Okay, it's not being generated here. So let me check it here. This one, XPath. So it's being generated at the time that we are creating the masking. Okay, so I'll be going to the MongoDB again, select the module. Okay, so I'll be passing for it. I'll not change this masking. Also, we have now in this new version, this possibility to export and import the configuration. And here I'll mask all the tables, and we can select confirm tables. Okay, we can put some preview. I think we have been discussed this. Here we can download the file before we go. So I'll be saving it. Okay, we are going to see that the file in a minute. Okay, sorry. Okay, we have a finder, so we can go all the way down. We're going to, okay, so here is the CSV file. We have the connection file, which is here. Okay, so we have also here this masking file. Okay, and see, you can see here for MongoDB, we generate the column. Okay, and then we are going to use this masking function for that, which is pre-configured in the previous screen. So here we can click mask and we confirm. Hopefully will be everything good. So we can fill the masking. Okay, we have 10,000 rows. Then we have here is the record. I'll refresh the page. Hopefully have been changed. Yes, everything has been changed. Okay, with that, I'll pass over to Pamela. Okay, I'm trying to get back.
Yeah, thank you.
Okay.
I appreciate it. So thanks to all of you for staying with us for our webinar today, and wanted to let you know that you all are unmuted at this point. So you're able to come off mute and ask a question should you have one. And in the meantime, I did get one question during the demos and presentation. They're asking if we support Hadoop Hive. Do we support that? Can someone answer that for the customer?
I think I can take that. So I think the question may be meant to be supported as part of this. So in fact, we have support for Hadoop Hive using the UDFs in the 4.10 release itself. But we are looking at ways to make it more native in the upcoming releases. but the support via UDF is already available to you right now.
Okay, I did get another question that was typed in. Can we mask XML files with this version?
Yes,
Yes,
sorry.
sorry,
Carry on,
now
Hudson.
we can. Yeah,
Yes,
we do support. Sorry, you can talk.
Okay. Yes, we do support XML masking. So that has been part of TDM functionality from previous versions, rather than being something new in version 4.11.
Okay, thank you. And Leela, did you want to come off mute and ask your question? Did you have a question?
Is there a limit on the count of rows it can mask?
There is no such limit. Really, the limit is really based on how long it will take, to do the masking. Sometimes you need a more powerful machine to perform such. If we're talking millions of rows, that's fine. You can talk billions of rows. That is also possible, but it's just a matter of having the environment that can handle that.
So sometimes had problems in getting the count of rows. When we used the parallel option, it could not get the count of rows due to the volume. So I think this would be taken care of, or it's just the matter of the machine which is in use.
Yeah, I mean, you're talking about masking, not data generation, just to make sure we
Masking.
are. Yes.
Yeah, masking. And that parallel option, right? Use the parallel option, which it checks
Yes.
the counts and then
Yes.
then does the parallel stuff.
Yep. I'm familiar. I'm familiar. Yes. Yes, we do support. Large scale, that's what we call large scale masking. When I say large scale, it can be large scale in terms of number of tables being masked, but also on the size of the table being masked. One table can have billions of rows, and you have thousands of tables that, as well. So in both cases, we do support that. There is some algorithm that that the portal can work out how to better handle and scale on the number of tables. For a specific table that has a very large number of rows, we have, again, like you said, large table split functionality that should handle the large tables to mask. If there are any issues that you encounter, then it's just a matter of reaching out, and we can help you out. But as far as the functionality, it is there.
Sure. Thank you very much.
Welcome.
Okay, it looks like we did have another question that came in. Do we get an option to support the masking for a few columns? Is there a revert option for it? Do we get an option to undo the masking for a few columns? Is there a revert option for it?
To undo the masking, yeah?
Undo.
Yes, it is possible, but that needs to be customized rather than out of the box. So I am aware that some customers requested that, but that needs to be part of customization rather than out of the box functionality.
Great. Are there any other questions from the audience? Again, you can take yourself off mute if you'd like and ask directly. Okay. I am not seeing any more questions coming in. So I just want to thank all of our panelists one more time for the great demos and the presentation that was given. Thank you very much. And thank you everyone for joining. I will be sending out again a link to the recording, so you will have that. With that, I'm going to end the webinar. Thank you very much.
Thank you.
Thank you all.
Thank you all.
Thank you. Bye.